Hello everyone, I hope you are good. This video is about permutation-based multigroup analysis, and I'm going to show you how you can establish measurement invariance based on MICOM procedure. You should know that establishing measurement invariance is a very important requirement for a meaningful multigroup analysis. Alright, so this is our example. And as you can remember, we have two predictors in our model. One of them is creating value that is measured reflectively. The other one is communication skills, that is a formative measurement model. We have job satisfaction, which serves as a mediator in our model. We have work motivation, that is the target construct in our model. And we also have age, which is a control variable. And so far we have tested two directional hypotheses, and these two are basically mediating hypothesis. And the third hypothesis that we are going to test based on our model is a multigroup hypothesis. So we would like to investigate if there are any gender differences in terms of any of the past coefficients in this model. And notice that our multigroup hypothesis is a non-directional hypothesis. So to test H3, what we are going to do is that we will run a two-tailed test. Alright, so this is the procedure for a permutation-based multigroup analysis. Basically, it has three steps. In the first step, we need to generate the data groups, and in the example that we are focusing on, the grouping variable is gender, so we have two groups. Group 1 is male and group 2 is female. Then in the second step, we have to test for measurement invariance based on MICOM procedure. And notice that MICOM procedure is also a three-step process. And then in the third step, we focus on analyzing and interpreting the permutation results. And in this slide, you can see the three steps for MICOM process. The first step is configural invariance. The second step is compositional invariance. And the third step is the equality of means and variances. So to establish configural invariance, you should consider identical indicators, data treatment, and algorithm settings. As an example, if you predict and replace the missing values in your group 1 based on expectation maximization algorithm or EM algorithm, you should consider this method for predicting and replacing missing values in your group 2. So if you fail to meet this requirement, it means that your multigroup analysis may not be meaningful. And in case that you meet this requirement, you can proceed to the second step, which is establishing compositional invariance. And to meet this requirement of the analysis, what you need to do is to focus on the original correlation between the composite scores that are obtained from group 1 and group 2. And basically, this original correlation should be greater than or equal to the 5% quantile of the empirical distribution of the correlations between the composite scores of group 1 and group 2. So if you fail to meet this requirement, again, you cannot proceed with your analysis. And in case that you manage to meet this requirement, and in other words, this original correlation is equal or greater than this statistic here, then you can proceed to the third step. And here you have to focus on mean and variance original differences and check if they fall between the upper bound and the lower bound of their confidence intervals. So if both of them fall between their confidence interval boundaries, you have established full measurement invariance. And in case that one of the mean or variance original differences falls between the confidence interval boundaries, it means that you have established partial measurement invariance. And in both cases, you can consider running multigroup analysis. Okay, now let's go to a smart PLS to check if we can establish measurement invariance in our model. Okay, this is my model, and the first step to run a permutation-based multigroup analysis is to create the data groups. So let me double click on my data file, and then from the toolbar I select generate data groups, and then from this list I select gender because gender is my grouping variable. And now you would see that I have 153 people that are male in my sample, and also I have 296 people in my sample that are female. So let me just close this, and then the next step is to click on calculate and then select permutation. And here I have to select my group 1 and my group 2. Make sure that you select 5,000 permutation subsamples, and also since our hypothesis is a non-directional hypothesis, we have to consider a two-tailed test, and the significance level should be 5%. So let me just click on the start calculation. Okay, now let me click on the MICOM hyperlink to see the results of the MICOM procedure. So here we have two tabs, step 2 and step 3, and in the first tab you could see the results for the original correlation between the composite scores obtained from group 1 and group 2, as well as the 5% quantile of the empirical distribution of the correlations. Note that these statistics, all of them are greater than these statistics, which means that we have established compositional invariance and we can proceed with the multigroup analysis. And another point here to highlight is that you don't need to report the results for age, because age is not a measurement model. So let's go to step number 3. Here also we would like to see all of the mean original differences to be between the lower bound and upper bound of the confidence intervals, and also the variance original differences to be between the lower bound and upper bound of confidence intervals. So for the means, you would see that for creating value, job satisfaction, and work motivation, these three statistics in green are between the lower bound and the upper bound of confidence intervals, which means that you can assume equality of the means for work motivation, job satisfaction, and work and creating value. But for communication skills, since this statistic in red is not between this statistic and this statistic, it means that we cannot assume the equality of means for communication skills latent variable. And focusing on the variance original differences, you would see that for all of our 4 measurement models, these 4 statistics are between the lower bound and upper bound of the confidence intervals. So it means that we can assume the equality of variances across our 2 groups for all of the 4 measurement models. Again, I remind you that you don't need to report the results for age, because age is not a measurement model. Now, in order to report the results, you can simply use this button to copy the statistics for step number 3 and step number 2 into one Excel file and create an informative table. Let me just show you how you can report the results for the MICOM process. Here I have all of my 4 measurement models. I have reported that I have established configural invariance for all of 4 measurement models. With respect to step number 2, I have reported the original correlations between the composite scores obtained from group 1 and group 2, as well as the 5% quantile of the empirical distribution of the correlations. Notice that since all of these statistics are greater than these statistics, I have reported the fact that compositional invariance has been established for all of 4 measurement models, as you can see it here. And with respect to full measurement model invariance assessment, I have reported the mean original differences as well as the variance original differences. I have also reported the confidence intervals, as you can see here, for both mean original difference and for variance original difference. And given the fact that the mean original differences for creating value, job satisfaction, and work motivation fall between the lower bound and upper bound of the confidence intervals, I have reported the equality of the means for these 3 measurement models. And with respect to equality of the variances, since all of these variances fall between the lower bound and upper bound of the confidence intervals, I have reported the fact that the variances are equal across my 2 groups. So since we have met the requirement with respect to compositional invariance, it means that we have achieved the partial measurement invariance and we can proceed with our multi-group analysis. And the last point that is important to highlight here is that in case you fail to meet the compositional invariance requirement for one or a few of the measurement models in your PLS model, what you need to do is to identify the problematic item or items and delete them from those measurement models. And if you do this, you will be able to establish compositional invariance requirement for those measurement models. So in the next video, I will show you how you can interpret the results of the multi-group analysis. Alright, thank you very much for watching and I hope you like this video.